So hello everyone, and we have another guest in our series of interviews today in MLOps World Conference. And today right now we have Hennes Hapke, who is a principal machine learning engineer at a company called Digits. And I would like to kind of understand what the company does and how did you end up in this position?
So Digits is taking the tedium out of bookkeeping. So we're using machine learning and artificial intelligence to provide business owners and our accountants insights into their books in real time. And that involves lots of machine learning problems, from like classifying transactions, named entity recognition problems, to GenAI problems or large language models to generate text for folks.
So I'll jump straight to it. We are in a GenAI themed conference. So how do you employ generative AI? Like, what are the main use cases?
So there's a couple of use cases we have. There's a use case where an accountant wants to talk to their client and figure out like, what is this transaction about? Maybe they're missing some context. So we're reading those transactions and then generating questions for the accountant that they can send them to their client. So previously they had to type them, and because nobody wants to type, nobody wants to spend the time, the question was always the same. So there was very little signal to noise to the actual operator or to the actual client. And so we now use GenAI to write custom questions for each individual transaction. So that way we can increase the signal to noise ratio for the user. We also implement some other LLM use cases where people can come to our tool, to Digits, and they can say like, what's my revenue this year? Generate me a report about 2022 compared to 2022 to 2023, those types of things.
And so how much of it is in-house built, and are you heavily leveraging some paid API like OpenAI or?
Yeah, that's a really good question. So we're looking very heavily of like what goes across the wire. So like, for example, if there's a problem where we just need to post-process something, we want to use like an LLM for that. That is something which can go to OpenAI. No customer data is going to OpenAI. We're heavily masking transactions and things like this. And if we do want to use customer data with an LLM, then we have the capabilities to fine-tune LLMs for specific purposes, and then we deploy them in-house and get those capabilities into the product that way.
So can you go maybe a little bit deeper into costs associated with hosting the models and maybe fine-tuning them yourself, and both like money costs and human capital costs and time costs? So how is it different?
It's vastly different. So if you look at, let's say, traditional deep learning, it's crazy to say that, but like let's say
already traditional.
So if we talk about the CNNs on maybe an LSTM model, you would spend the majority of the money goes into the training. You have your GPUs, you have your GPU cluster. If you pre-process all the data, you train your models. This is basically where you spend the bulk of the money per hour. And then the hosting can be fairly inexpensive, but because if you quantize your models, if you optimize them, you can run them on on CPUs. So you can cut out a lot of costs of your deployment setup there. All these optimization methods haven't been too fruitful on our side for LLMs. So the cost flips a little bit. Yes, you have to spend a lot of money on like fine-tuning them, but actually the hosting them for 24/7, that's large chunks of money you have to like spend to actually get those models into production. We have seen really cool tools coming up these days of like reducing the costs, like for example, not requiring A100s, using smaller instances, reducing the cost that way. And so we're actively working on getting them into production, getting those setups into production so that we can also reduce our LLM costs.
Okay, and so how big are the models that you're hosting? Are they somehow compacted, compressed, or are you just going all in with, let's say, llamas? And
we do have some applications where we use like Llama 2. We do have in terms of like the large 7 or 13 billion parameter model, this would be the Llama 2s. We do have some applications where a T5 model does really well. So we obviously always evaluate like for this given problem, what is the cheapest model we can deploy, and in some cases it is like a good T5, a really well fine-tuned T5, or in some cases it's like a Llama 2, fine-tuned Llama 2.
And when it comes to, let's say, proportion of how many classical machine learning models you have, classic standard, and how much of GenAI you actually employ in your business, so how it would look like.
I think at the moment it's sort of like 70-30, and it might shift. So 70 is like traditional machine learning, 30% is like LLM-based machine learning. The core of the machine learning work is around what we call subjective machine learning. You can have a transaction, and it could be like a Starbucks transaction at an airport, and some accountant will say, this is a meal, and some other accountant will say, no, this is actually a travel expense. So they would have two different classifications. Both of them are correct. They're subjectively correct. And so we have to support those use cases. We can't have like one straightforward classification model. And so the way we solve those problems is like generating embeddings and having like various systems to consume those embeddings. And the majority of the machine learning projects go into like optimizing those embeddings, fine-tuning them, etc. And then on top of that, we have our typical classification problems, NLP problems, computer vision. We spend a lot of time on like understanding documents, those types of things.
Okay. So I guess the question would be, which part was the hardest to solve? Like when it comes to generative AI, like there's a lot of articles where you can just say that you take a model, you fine-tune it, you deploy it. Job well done, right? Now, what was actually the hardest part that is not that often talked about?
I think there's a lot of, I don't know, there's a lot of interesting problems in terms of like evaluating LLMs is a really interesting problem, right? It's like we're continuously just working on this. Like, I don't know if anybody has like the good solution for this. Another hard problem was like, how do we actually host them internally? So when we started, we started testing setups with like Llama. We didn't use it in production, but we were really keen on like, can we understand like how we would fine tune or deploy those models? And at that time, nobody has really talked about like how you would even deploy an LLM internally. It was just coming up. So these days, there's a lot of good documentation. There's a lot of good tools. So the problem got much simpler, but back in the day, it was like one of the hardest problems to like, how do we actually serve?
So I guess evaluation problem still remains, right? Maybe now it's serving problem is not that difficult to solve now, but I guess evaluation is still there, right? So what kind of methods do you employ to evaluate the large language model?
Yeah, so we want to make sure that when we evaluate the models, we want to make sure that the generated text is like semantically correct. So it's semantically very close to the text we have in our example sets. But we want to be language diverse, meaning we want to be far away from the example sets. We don't want the model to memorize our training sets, right? We want to see differences with different temperatures and those types of things. So there's sort of like the trade-off between, yes, we want high similarity, but we basically want like a low Levenshtein distance, or sorry, a low Levenshtein similarity. Like we want we want to be far away from those two sentences should be like completely differently expressed.
And when it comes to using the large language models to evaluate large language model outputs, are you employing that strategy, or using large language models to evaluate outputs of other large language models? I've heard that like it's a very popular approach.
That is a very popular approach. That's something we are actively looking into, and I don't think we have concluded on whether it's worthwhile or not.
Okay. Okay, so I think we are actually running out of time. So we are past the time agreed. And thank you for being with us. Thank you for answering some questions. And now maybe a few thoughts from your side to our listeners, where we can find you, yourself and your company.
So you can find Digits at digits.com. We do have a really very detailed engineering blog where we post a lot of ML machine learning blog posts about like how do we do simulator-based machine learning, etc. So if anybody's interested in how we solve production machine learning use cases, hop over there on digits.com, find the engineering block, and then you can find more information there.
We'll add everything under the video where we post it so that everyone can find you.